Hey everyone, welcome back, and in this video let's start with solid principles. So let's see one by one what are solid principles. Now see, solid principles, basically the word SOLID consists of 5 principles that are stated right on your screen. So if I zoom in a little bit, so solid principles, basically S refers to single responsibility principle, O that means open closed principle, L basically means Liskov substitution principle, I stands for interface segregation principle, and D stands for dependency inversion principle. Now I won't be coding all the 5 principles, right, because these principles are more of understanding and less of coding, but just in case while giving an example I thought that maybe it's a good thing to code, so I'll surely code. Okay, so let's start. Now first one is single responsibility principle. Now what this says that each class and each method should only and only be responsible for doing one task. For example, if you are creating a function, let's say wash car, now that particular function should only and only be responsible for washing the car, correct? That function should not worry or take care about any other responsibility. Similarly, if I talk about a class person should have methods only related to the person, right? So single responsibility says that there should be only and only single responsibility given to a particular function. Okay, don't try to solve more than one problem inside one function. Create 2 separate functions and then combine them both. But a single function should always and always have one responsibility, and that's what the single responsibility principle states. Second, we have open close principle. Okay, now what is open close principle? It basically says that your class should be open for extension but should be closed for modification. Okay, what does that mean? If I take an example of, let's say, Chrome, okay, and the Chrome browser has some extensions that you can install, correct? Which is a good thing, right? Because it extends the functionality of a Chrome. So it says that if you are making a class, it should be open for the extension. For example, what we did, if I take example of the class car, we made a class BMW which extended the class car, correct? And that BMW added a brake functionality to it. So that was a good pattern. So basically our class should be open for extensions but should be closed for modification. Like, I don't want someone to modify my class directly, right? So my class should not be modified, but yes, it should be extended. So that's what open close principle says. Then we have Liskov substitution principle. Okay, now what does this Liskov substitution principle says? It says that if a method, like for example, there is a class A which is a parent class and there is a class B which is a child class. Okay, now if a function accepts class A as an argument, then class B should also be acceptable. Okay, let me show you an example. So let's see an example of this Liskov substitution principle. Okay, for example, let's say you have a class rectangle, which is okay. Now what are the properties of a rectangle? It has a width, it has a height, correct? And in this example, what they did, they basically made a constructor which is setting the width and the height, pretty basic. And then they have, getters and setters, which we have already done. And here is a function to get area, which returns width into height. Okay, now this is a rectangle class, correct? Now, can I make a square out of rectangle? Yes, I can. So what I can do, I can have a class square, which basically extends the rectangle class, which is okay. Now see what they are doing. They are basically making a constructor in which they are forcing the width and the height to be same. In simple terms, square is also a rectangle with width and height equal to each other, right? And then rest everything is same, right? Now what if I say that, hey square, go ahead and get me a width? Will that work fine? Obviously that will work fine, because see, we should not make any get width method in the square, because that is already present in the parent class. So get area. So if someone tries to create a square and calls get width function, get area function on the square, he will get the exact same result, basically the correct result that he wants. So basically what this principle says, this Liskov substitution, it says that given that class B is a subclass of class A, okay, so that means class A is the parent and class B is the child, we should be able to pass an object of class B to any method that expects object A. So in the below example, if some function is accepting the rectangle, so we can even pass square there, because we have merged it very nicely. So basically where the trick part was that we made a constructor where we set the width and the height to equal, width and height equal to each other, which basically enables us to reuse the rectangle as a square. So this was Liskov substitution principle. Now next on our list is interface segregation principle. Okay, now this is a little bit interesting, and let's code this one. Okay, let's code this one. This is the code from our previous video, so let's remove this code. Okay, and I want to really show you a very good example. So let's remove this one. Okay, so we are talking about the I of the solid, which is interface segregation principle. Let's say you have a class animal. Okay, now an animal can has, okay, let's make a public for now because I don't want to waste time making getters and setters. Public string name of the animal. Okay, that's it. Now let's have a function. Okay, let's have a function which enables us to pet this particular animal. So I'll say pet, and I'll say s out that the name is now your pet, right? And which is perfectly fine, correct? Now see what happens, and let's make one more function, that public void walk. Okay, and I can say s out that name is walking. Similarly, animal can have 100 more methods. Now let's say I have a class dog, okay, which extends animal, which should extend animal, I would say. And then we have a class lion, which again extends animal, because they are both are same in behavior, correct? Now see, where's the problem? If I make a object of dog, so I say new dog, and let's name our dog. So I'll say, hey dog, your name is Tuffy. Okay, Tuffy. And let's make a lion as well. So I'll say lion equals new lion, and I would say that, hey lion, go ahead and your name is lion. Now see, where's the problem is, can I say that lion, you can walk, which is perfectly fine. I can even say, hey dog, not do, hey dog, go ahead and walk, which is perfectly fine. Let's make dog a pet, which is absolutely fine. But the problem occurs when I try to pet a lion. So is it technically possible to pet a lion? I don't think so, until and unless you are living in Dubai, correct? So technically this lion should not be pettable, but this dog should be pettable. Now what should I do? So the mistake is that I have put this pet particular thing inside the animal class, correct? Now you would say, just do one thing, remove it from here. Okay, remove it from here and put it in the dog class. But now the problem occurs, let's say that there was a class cat, there was a class something else which are pettable. So I need to repeat my code, and you violate one property, that is don't repeat yourself. So what's the solution? Now the solution is, see what I can do, I can have a class. Okay, let's say pet ape, not the class, I can have a interface. Okay, interface, I can say petable. Okay, petable. And in this petable, what I can do, I can basically have this function. Okay, so I can say void pet. Okay, void pet. Now what I can do, I should say that this dog implements petable. Okay, now as soon as I say petable, I need to create this function. So I can say void pet. Okay, and then I can say s out that name is now a pet. Okay, so void pet. Yeah, what error we are getting? Public was the error. So now you can see I have put a petable right here. Now see, I cannot pet a lion, but I can pet a dog. So dog is now petable and lion is now not petable. Okay, so that's what the interface segregation principle says. So it says that segregate your interfaces, and try to put minimal things into it. Don't just make too much generic things. Like animal, most of the animals are petable, but that does not mean that you will put the pet function inside the animal, which will eventually make lion, tiger and these kind of animals also petable. So you should always segregate your interfaces according to your needs. Then last, it is dependency inversion principle. Now what is this? Now the dependency inversion principle states that class should depend upon the interfaces or abstract classes instead of concrete classes. Okay. Now what is a concrete class? In this example, this animal is a concrete class. Why? Can I make object of this animal? Absolutely yes. So this is a concrete class. Okay. Any class is known as concrete if I am able to make object of it. So animal is a concrete right here. Okay. And we should not make these classes, okay, these classes depend upon a concrete class. So this thing is wrong. Basically we are extending a animal class which is a concrete class. Rather, we have already seen in the car example, we should make this class abstract. Okay, we should make this class as abstract, and then we should inherit the properties. Okay, so it says that a class should not depend should depend upon interfaces and abstract classes instead of concrete classes. So either you make interfaces and segregated interfaces, okay, so or either you make abstract classes and then you should basically inherit them. Don't use inheritance or don't depend upon concrete classes. So this was solid principles. I know principles can be a little bit boring, or it might feel like, where are these even used? So these are just principles that you should know. You should just know that things like these exist. You should know that there is something known as dry that exists. There is something solid principles that exist. So these are nothing, just, some couple of principles that you should know. And here comes the end to this section. So these were all the principles that were most commonly used. So we know dry, we know kiss, we know yagni, and we know solid principles. And from the next session, let's start with design patterns.